Okay, so my name is Adam Grunster, and I am, this is my final project presentation for CS 6963. Professor Fernandez's digital forensics class is August 16th, 2013, and I will be talking about PDF digital watermarking. So the introduction, what is a digital watermark? It's a technique that embeds information into a form of digital media, such as audio files, video files, or document files. Why do we use digital watermarks? There are a variety of reasons. The most important is copyright protection. There's also source tracking, transactional watermarks or fingerprinting, and covert communications. Watermarking is similar to steganography or information hiding. It requires an embedding algorithm, and then that algorithm is used in reverse to extract the watermark. So there are two main types of digital watermarks. There are visible watermarks and invisible watermarks. Visible watermarks are embedded in such ways to be obvious. An example would be the word draft or confidential across a document, or the author's name in semi-transparent text across the document. Similarly, the photographer's name across a photograph would be an example of a visible watermark. Invisible watermarks are embedded in such a way that the presence is not obvious to the user. CDs and DVDs nowadays, some of them have invisible watermarks as well. So watermarks can further be classified based on robustness and domain. Robustness is a watermark's ability to resist attack, and domain is where in the cover media the watermark is embedded. So robustness is a watermark's ability to resist attack, and watermark attacks are intended to modify or remove the watermark. We won't discuss watermark attacks in this project. There are three classifications of robustness. There's fragile watermarks, which are not able to resist any type of attack. There are semi-fragile watermarks that are able to resist certain attacks but not others. And then there are robust watermarks that are able to resist all types of attacks. So a watermark domain refers to where the watermark has been embedded in the cover media. There are three classifications here as well. The spatial domain, which is the actual image space. The frequency domain, which is frequency patterns of the cover image. And then you have the wavelet domain, which involves the resolution manipulation of the cover image. So in the spatial domain, like we said, refers to the actual image space of the cover image, and altering the image space will alter the image in some way. So one technique is least significant bit modification, and it's used to replace the least significant bit of a pixel byte with one bit of the watermark. And you can do this sequentially across any number of pixels, or you can use some sort of secret key to distribute the watermark amongst the pixels. Another technique is called information tagging, where it's used only with images, and information tagging manipulates the image properties such as brightness. So with the frequency domain refers to how quickly the cover media is changing. An example would be a text document or something. This would be a high frequency component to the cover media, so that means that the data is changing rapidly, such as in a text document. Or you have low frequency components of the cover media, which means that the data is more uniform. So if you have an image or a picture, and you have the sky is all the same color, that would be a low frequency component of the cover media. So then this thing called discrete cosine transformation is a method to divide the cover media into these frequency groups, and then the watermark is then distributed amongst the least important frequency groups. So with wavelet domain, watermarking in the wavelet domain involves the discrete wavelet transformation, which is used to create different resolutions of the cover image, and the watermark is then embedded in the high resolution areas of the cover media. So this project didn't really deal with the wavelet domain or the frequency domain, but the wavelet domain watermarks do tend to be more robust than either the spatial or the frequency watermarks. So with the application of watermarks, you've got large amounts of digital media available to the public nowadays, and copyright protection is the most important use of these digital watermarks. Like I said earlier, you can have watermarks in CDs and DVDs. You can even have watermarks or media players that look for these watermarks and won't play the media if they don't contain the watermark. There's also source tracking, where the media gets a watermark at each distribution point, and then you can use that to track back to the distribution points or the sources. Transactional watermarking involves putting recipient information in the watermark instead of just source information. An example might be a movie company releasing preliminary release of a movie to a few critics, 5-10 critics. They want to be able to track which copy went to which recipient. So if there's a leak, they can track that back to the originating recipient. You've also have broadcast monitoring, and this is used in radio ads. So there was a cool story in one of these papers that I read that in Japan in 1997, some radio companies or radio broadcasters were overbilling for their ad space, and there was no real way to track for the advertisers whether they were getting the amount of time that they paid for or not. And so people started putting watermarks into these radio ads, and then they actually have listening stations listen for the radio ads, and they can detect the watermark, and so that they know that they're getting what they paid for. And then watermarks can also be used with covert communications. Like we said earlier, it's a similar process to steganography, but if you just swap out a watermark and put in a secret message, or the watermark is the secret message, then you enter the realm of covert communications. So with a watermark detector, there were many audio-video watermark applications out there. There were fewer document watermarking applications, so I wanted to kind of go that route. My initial project goals were to build just a general watermark detector that would detect all watermarks, all types of watermarks in a PDF file. I quickly realized that this was way too broad of a scope based on all the multiple types and classifications of watermarks that we have talked about. So I changed my project goals to focus on only visible watermarks and exclude invisible watermarks altogether. So a common way to watermark a document is this semi-transparent text, draft, confidential, author's name, whatever, across all the pages of a document. It's easy to detect when you're reading the document, obviously, but it's inefficient to go and look at every single PDF file in a folder to see if it contains a watermark. So there has to be a way to detect a discrepancy between the watermarked PDF and the non-watermarked PDF, and so I needed to understand the PDF file structure before I went any further. So PDFs have 4 components. You've got a header, a body, a cross-reference table, and a trailer. The header simply contains PDF version information. All the objects in a PDF are located in the body, and those are all the objects is what the user sees, and so all that stuff is located in the body. The cross-reference table is used for random access of PDF objects, and it contains a byte offset to each object from the start of the PDF file. And then the trailer is actually read first by any sort of PDF reading application. That application starts at the trailer, and it looks for the cross-reference tag, which is a tag to the start of the cross-reference table. And then the trailer also contains a size tag indicating the size of the cross-reference table, which is just the number of objects in the body. So the next step would be comparing PDFs, so looking at 2 PDF files, one watermarked, one not, and then trying to find the differences. So I use LibreOffice. I'm running Ubuntu on my laptop, and I use LibreOffice to create text-based watermarks and to create PDF files. Excuse me, the text-based watermarks were huge green text that LibreOffice put in the PDF. I used just the word draft or confidential or something like that. So the problem that I ran into here was that there was nothing special about the new object stream to differentiate it from the valid text in the PDF. So the fact that there was a new object in the PDF was fairly obvious when I looked at the body of the PDF, but there was no information in the new object that said this is a watermark as opposed to this is regular text. So the next step was to take a look at images as watermarks, another common document watermarking technique to embed images into the background of documents. LibreOffice does not do any JPEG embedding into PDFs, so I created a little program using iText to embed JPEGs into PDF files. And so initially all this did was it used 2 methods called over content, or it used under content that would just take a JPEG and put it into a PDF file, and all that did was create an object with a JPEG in it. Either, I think, over content put the JPEG as the first image or the second image, or excuse me, the first object or the second object towards the beginning of the body, and under content put it towards the end of the body. So another problem that I ran into here, I was going to try to see if I could use the location of the object in the body as an identifier. If I used over content or under content, I could then locate that object as the first or the last object. But that seemed kind of like a large assumption, and so that didn't really help me in any way. And then I figured, well, we've been talking about magic numbers in class. I can use this JPEG FFD8 to identify the JPEG. And that was easy to do when looking at the PDF in a text editor. It was very easy to identify that magic number. But again, I ran into the problem of how do I tell that this is a watermark and just not another JPEG. So I ended up changing my final project goals again last time, and the project goals changed to include the assumption that some sort of identifying mark would need to be embedded along with the watermark. And so I guess this is analogous to embedding the embedding algorithms we discussed earlier. And to ensure that this project actually worked and everything was feasible, I used a simple form of a mark, and I ended up embedding the watermark into a new PDF layer and then using the PDF layer name as the identifiable mark. So the outcome of the PDF watermark detector, the detector was able to scan a folder full of PDF files and return whether or not the PDF file contained a watermark by simply searching through all the PDF layers for a layer named watermark. If a PDF was watermarked, the program dumped out all sorts of file information and PDF metadata into a SQLite database before moving on to the next file. And so the information that I collected is file name, file path, title, subject, keywords, creator, creation date, author, etc. I think there is a good amount of future work that can be added to this project. My project focused primarily on non-proprietary PDF software. Future endeavors should include files generated by Adobe Acrobat. I think there's a further examination of JPEG magic number identification techniques. If there's a way to identify all of the JPEGs in a PDF file and then compare the JPEGs to one another to look for outliers or kind of which of these JPEGs doesn't belong sort of thing, that might prove useful. And then similarly with the text-based watermarks, if you look at font size, font style, orientation, all those attributes could play a role in differentiating text-based watermarks from valid text in the PDF file. And we seem to be running into some problems here. So that's the end of the report for my works cited list that will be included in my in the actual final project report. So we'll see if we can get a project demo going here. Okay, so here's the, we'll get a little project demo going here. I need to take a look at a folder real quick, so let me pause. Okay, so I'm in my Grunster Final Project folder. The only thing of real interest here is the SQLite JDBC jar file needs to be in the same folder as the Java programs. The has watermark program needs that to be added to the class path. As we can see here, so if you just do a Java dash class path with the SQLite JDBC, has watermark should work. Otherwise, it'll throw up a SQLite error. So we can see that there are 5 PDFs that we scanned, 2 of which contain watermarks. File number 1 contains a watermark, and file number 3 contains a watermark. These other files do not. If we look at SQLite in our sample database, oops, We see that we've got a PDF report table. If I could type it. We see here we've got two entries. One is the new PDF results.pdf. And here's our path, watermark PDF. It's just in the watermark PDF folder. And then we've got a title of the document, subject. This is the keywords. And then we've got over here, this I believe was how it was created. And then we've got a creation date, which is kind of important, and the creator. And then I thought this was pretty neat. It put the LibreOffice 4 in there as well as the application that created the document. And then we've got our second PDF that contained a watermark, which was add watermark results, and we've got the similar metadata, different creation date, that type of thing. So that's it. That is my watermark detector. Thank you very much.